Now in this lecture we'll find out the length of line segment X. In the drawing we have a regular hexagon. A regular hexagon is a closed polygon with 6 equal sides and 6 equal angles. And we know that side AB equals to 2 units, therefore all the other sides of this regular hexagon must be also equal to 2 units. So here FA equals to 2 units, EF equals to 2 units, ED equals to 2 units, and here CD is also equals to 2 units, and CB equals to 2 units, and all the 6 interior angles, 2, 4, 6, also equal to each other. And finally, it is given us the equation that side PB equals to, or line segment PB equals to 3 units. Our mission is to find out the length of PA, line segment PA, that is equal to X. So first of all, we find out the sum of the angles in any regular hexagon. So I draw a regular hexagon that could be any regular hexagon, and we find out the sum of the angles in that regular hexagon. Here A, B, C, D, E, F, it is a regular hexagon. That is to say, all of its sides are equal to each other, and also all of its six interior angles are also equal to each other. We join points B and E by a straight line. By joining points B and E, we actually created here 2 quadrilaterals. We know that the sum of the angles in any quadrilateral is equal to 360 degrees, therefore the sum of the angles in this quadrilateral ABFE is equal to 360 degrees, and the sum of the angles in quadrilateral BCDE is also equals to 360 degrees. And because of the fact that this regular hexagon consists of 2 quadrilaterals, it means that the sum of the angles on those 2 quadrilaterals will be equal to the sum of the angles in this regular hexagon. So 360 degrees plus 360 degrees, it will be the sum of the angles in this regular hexagon. This is actually equal to 720 degrees. And because of the fact that this regular hexagon ABCDEF could be any regular hexagon, we actually found out that the sum of the angles in any regular hexagon, it is equal to 720 degrees. And this regular hexagon, as any other regular hexagon, consists of 6 interior angles, 2, 4, and 6, they are equal to each other. And therefore, the size of one interior angle of this regular hexagon will be equal to the sum of the total angles, total interior angles in this regular hexagon, that is 720 degrees, over the number of the angles, over the number of the interior angles in this regular hexagon, that is actually 6. Therefore, the size of one angle, one interior angle in any regular hexagon, it is 720 degrees, over the number of the angles, that is 6. 720 degrees over 6 is 120 degrees. So we found out that the sum of the angles in any regular hexagon equals to 120 degrees. So we can write down that this angle equals to 120 degrees in its size. This angle is also equals to 120 degrees in its size. This angle equals to 120 degrees. This angle equals to 120 degrees. This angle equals to 120 degrees, and this angle, it is also equal to 120 degrees in its size. And we will extend side DC by a straight line. DC is one side, one out of the 6 sides of this regular hexagon, and therefore it is absolutely a straight line. Okay, so DC is a straight line. Why? Because okay, DC is one side of this regular hexagon, therefore it is a straight line, and we extended the straight line DC by a straight line. We will define this point as L. When we extend a straight line by a straight line, the result is a straight line. So we can write down that DL is a straight line. And we have rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the left side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at this side of DL at point C? We have 120 degrees plus the missing angle, angle BCL. In total, the sum of those two angles must be equal to 180 degrees according to rule number 1. So 120 degrees plus the missing angle, that is actually this angle, angle BCL. In total, the sum of those two angles must be equal to 180 degrees according to rule number 1. Here we subtract 120 degrees from this equation, and we'll get that the missing angle, angle BCL, equals to 180 degrees minus 120 degrees, it is 60 degrees. So this missing angle, angle BCL, equals to 60 degrees in its size. In the next step, from point B, we'll go perpendicular on DL. Again, from point B, we go perpendicular on DL. So here, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DL as M. By doing this construction, we created here the right triangle BCM. So I copy the right triangle BCM in the new page, and we'll analyze it. So actually, this is the right triangle BCM that I copied from the original drawing. BC equals to 2 units because it is one out of the 6 sides of the regular hexagon ABCDEF, therefore it is equal to 2 units. Because of the fact that all of its sides are equal to 2 units. This angle equals to 90 degrees according to our construction. This angle equals to 60 degrees according to rule number 1. In the right triangle BCM, cosine 60 degrees cosine 60 degrees equals to CM over CB. Okay, cosine 60 degrees equals to CM over CB. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2, and it is equal to CM. CM is the missing 9 segment, so we leave it as it is, over CB. CB equals to 2, so we substitute CB by 2. In conclusion, we found out that 1 over 2 or 1/2 equals to CM over 2. Here we'll multiply this equation by 2, and we'll get that CM equals to 1 unit. Here CM equals to 1 unit. I on the original drawing that CM equals to 1 unit. Likewise, we continue to focus on the right triangle, triangle CMB. In this right triangle, triangle CMB, sinus 60 degrees equals to MB over CM. MB over CM. Again, sinus 60 degrees equals to MB over CM. Sinus 60 degrees is square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2, and it is equal to MB. MB is the missing side, so we leave it as it is, over CM. CM equals to 2, so we substitute CM by 2. In conclusion, we found out that square root of 3 over 2 equals to MB over 2. We will multiply this equation by 2, and we get that MB equals to the square root of 3 units. MB equals to the square root of 3 units. You can write down the original drawing that MB equals to the square root of 3 units. Okay, in the next step, we'll focus on the right triangle, triangle PMB. In this right triangle, triangle PMB, PM is the missing 9 segment, so we'll define PC is the missing 9 segment, therefore we'll define PC as A. PC equals to A according to our definition. Therefore PM, side PM equals to PC plus CM. Again, PM equals to PC plus CM, that is to say, PM equals to PC that is A plus CM that is 1. So in conclusion, we found out that PM equals to A plus 1, BM equals to the square root of 3, and the hypotenuse BB equals to 3. So we'll copy the right triangle, triangle PMB in the new page, and we'll implement the Pythagoras theorem in this right triangle, triangle PMB. So this is the right triangle, triangle PMB, that I copied from the original drawing. PM equals to A plus 1, MB equals to the square root of 3 units, and the hypotenuse BB equals to 3 units according to what is given as the question. So we'll implement the Pythagoras theorem in this right triangle, triangle PMB. This triangle equals to 90 degrees according to construction. So here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle PMB is PB, therefore the square of the hypotenuse is PB squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to PM squared plus MB squared. In conclusion, according to the Pythagoras theorem, in the right triangle PMB, we found out that PB squared equals to PM squared plus MB squared. PB is 3, therefore PB squared is 3 squared, that is 9, and it is equal to PM squared. PM is A plus 1, therefore PM squared is A plus 1 squared plus MB squared. MB is equal to 3, therefore MB squared is equal to 3 squared. In conclusion, we found out that 9 equals to A plus 1 squared plus square root of 3 squared. Square root of 3 squared is 3. Here we subtract 3 from this equation, and we get that 9 minus 3 is 6, so 6 equals to a plus 1 square. Here we take a root out of this equation, and we get that the square root of 6 equals to a plus 1. Here we subtract 1 from this equation, and finally we get that a, the missing 9 segment, equals to the square root of 6 minus 1 units. So we can write down in the original drawing that the missing 9 segment A is equal to PC. It is equal to the square root of 6 minus 1 units. Okay. So in the next step, we will join points A and B together, points A and C together by a straight line. By joining points A and C, we create triangle ABC. This is triangle ABC. In this triangle ABC, angle ABC, this angle ABC, it is one out of the 6 interior angles of the regular hexagon, and we know that each interior angle is equal to 120 degrees. Side AB equals to 2 units and side BC equals to 2 units. So I'll copy triangle ABC in a new page, and we'll implement the law of cosines in this triangle ABC. But first of all, I will remind you what is the law of cosines. The law of cosines is true in any triangle. So if we have a triangle ABC, that could be any triangle. This is triangle ABC, and the length of side AB is A, side AC equals to B units in its length, and finally side BC equals to C units in its length, and the angle between side AB and side AC is theta. Then according to the law of cosines, that is true in any triangle, we will get that C square equals to A square plus B square minus 2 times A times B times cosine theta. So in any triangle, C square equals to A square plus B square minus 2 times A times B times cosine theta. We will implement the law of cosines in our triangle ABC. So I will copy triangle ABC in a new page, and we will implement on it the law of cosines. Angle ABC equals to 120 degrees, side AB equals to 2 units, side BC equals to 2 units. So actually this is triangle ABC that I copied from the original drawing. Side AB equals to 2 units, side CB equals to 2 units, and this angle ABC equals to 120 degrees. So according to the law of cosines, we get that AC squared equals to AB squared plus CB squared minus 2 times AB times CB times cosine 120 degrees. So this equation is the implementation of the law of cosines in our triangle ABC. AC square equals to AB square plus CB square minus 2 times AB times CB times cosine 120 degrees. Okay, so AC square equals to AB square. AB is 2, therefore AB square is 2 squared, that is 4, plus CB square. CB is 2, therefore CB square, it is 2 squared, that is 4, minus 2 times AB is 2, CB is also 2, times cosine 120 degrees. Cosine 120 degrees equals to minus 1 half, so we substitute cosine 120 degrees by minus 1 half. So in this expression, we have minus times minus, that is plus, so in total this expression will be a positive number. So we have here 2 times 2, that is 4, and 2 over 2 is 1. So those 2 will get cancelled and we left only with 4. Okay, so in conclusion, we found out that AC square equals to 4 plus 4 plus 4. That is to say, AC square equals to 4 plus 4 plus 4, that is 12. Here we substitute 12 by 4 times 3. So AC square equals to 4 times 3. Here we will take a root out of this equation and we will get that AC equals to the square root of 4 times 3. Here we take 4 out of the root and we get that AC equals to the square root of 4 is 2. Inside the root we left only with 3. So in conclusion, we found out that AC equals to 2 times square root of 3 units. So we can write down here that the left side AC equals to 2 times square root of 3 units. In the next step I will copy again triangle ABC in the new page in order to find out the sizes of those two angles. Okay. So this is actually triangle ABC that I copied from the original drawing. AB equals to 2, BC equals to 2, and angle ABC equals to 120 degrees. Because of the fact that those two sides are equal to each other, they are both equal to 2 units, therefore they are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, in front of those two equal sides, we have those two equal angles. So those angles are equal to each other, so if this angle equals to x, then this angle must be also equal to x. And we also know that the sum of the angles in any triangle is 120 degrees, and especially in triangle ABC. So which angles we have here? We have this angle that is equal to x, plus this angle that is x, and plus 120 degrees. In total, they must be equal to 180 degrees. So x plus x is 2x, plus 120 degrees is 180 degrees. Here we'll subtract 120 degrees from this equation, and we'll get that 2x equals to 180 degrees minus 120 degrees, it is 60 degrees. So 2x equals to 60 degrees, we'll divide this equation by 2, and we'll get that x equals to 60 over 2, that is 30 degrees. So x equals to 30 degrees, and here x equals to 30 degrees. But this angle, it is angle ACB, that is to say angle ACB equals to 30 degrees. So we can write down here that this angle ACB equals to 30 degrees. Okay, so here we have the big angle PCB, that is equal to 120 degrees. The small angle ACB equals to 30 degrees. Therefore, this missing angle PCA will be equal to the big angle minus the small angle. So I copy those angles again in a new page. we have the big angle, angle PCA. This angle is equal to 120 degrees. So this is the big angle, angle PCA, that is equal to 120 degrees. This small angle, angle PCA, equals to 30 degrees. It is actually angle ACB. The small angle ACB equals to 30 degrees. This is the small angle ACB that is equal to 30 degrees, and therefore the missing angle, angle PCB, equals to the big angle minus the small angle. Okay? So the missing angle, angle PCA, equals to the size of the big angle, that is actually angle PCA, minus the small angle, that is angle BCA. So the missing angle, this missing angle, angle PCA, it is equal to the big angle PCA, that is equal to 120 degrees, minus the small angle BCA, that is equal to 30 degrees. That is to say, we found out that the missing angle, angle PCA, equals to 120 degrees minus 30 degrees, it is 90 degrees. So we found out that the missing angle, angle PCA, it is a right angle, it is equal to 90 degrees. So this angle equals to 90 degrees. And because of the fact that angle PCA equals to 90 degrees, it means the triangle, this angle PCB equals to 90 degrees, it means the triangle PCB is a right angle. Okay. So this is the missing angle, angle PCA. Angle PCA is the missing angle, and it is equal to 90 degrees. This is the missing angle, and because of the fact that this angle equals to 90 degrees, it means the triangle PCA is a right angle. Okay? So I'll copy the right angle triangle PCA in a new page, and we'll implement the Pythagoras theorem in the right triangle, triangle PCA. This is point B, and this is point A. Here, angle ACB equals to 30 degrees, as you can see here, angle ACB equals to 30 degrees, and therefore triangle PCA is a right triangle. So angle PCA equals to 90 degrees, therefore triangle PCA is a right triangle. This triangle PCA is a right triangle, therefore I'll copy the right triangle, triangle PCA in a new page, and we'll implement on it the Pythagoras theorem. So this is the right triangle PCA that I copied from the original drawing. PC equals to A equals to square root of 6 minus 1 units. CA equals to 2 times square root of 3 units, and PA equals to X according to what is given us in the question. So here by PT is a progression for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In this right triangle PCA, the hypotenuse is PA, therefore the square of the hypotenuse is PA square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PC square plus CA square. So according to the Pythagoras theorem, we found out that in the right triangle PCA, PA square equals to PC square plus CA square. PA is X, so PA square is X square, and it must be equal to PC square. PC is square root of 6 minus 1, therefore PC square is square root of 6 minus 1 square plus CA square. CA is 2 times square root of 3, therefore CA square is 2 times square root of 3 square. Okay, so actually we found out that X square equals to the square root of 6 minus 1 square plus 2 times square root of 3 square. So X square equals to the square root of 6 minus 1 square plus 2 times square root of 3 square. 2 times square root of 3 square equals to 2 square, that is 4, times square root of 3 square, that is 3. 4 times 3 is 12. So we concluded and found out that X square equals to the square root of 6 minus 1 square plus 12. In order to find out the value of the expression square root of 6 minus 1 square, we use here the algebraic identity that states that A minus B square equals to A square plus B square minus 2 times A times B. In our specific expression, A equals to the square root of 6 units and B equals to 1, and therefore, according to this algebraic identity, minus 6 and square root of 6 minus 1 square, or square root of 6 minus 1 square, according to this algebraic identity, will be equal to A square. A is square root of 6, therefore A square is square root of 6 squared, that is 6, plus B square. B is 1, so B square is 1 squared, that is 1, minus 2 times A is square root of 6 times B, that is 1. So in conclusion, we found out that the value of this expression, square root of 6 minus 1 square, equals to 6 plus 1 minus 2 times square root of 6. So here we'll substitute this equation, square root of 6 minus 1 square, by 6 plus 1 minus 2 times square root of 6. And we'll get that X square equals to square root of 6 minus 1 square. It is actually 6 plus 1 minus 2 times square root of 6 plus 12. So in conclusion, we found out that X square equals to 6 plus 1, that is 7, minus 2 times square root of 6. Here we'll take a root out of this equation, and we get that X, actually here, X square equals to, here 6 plus 1 is 7, and 7 plus 12 is 19. So it is 19 minus 2 times square root of 6. Here we take a root out of this equation, and we get that X, the line segment that we are looking for, equals to the square root of 19 minus 2 times square root of 6. Okay, or there are some numbers, it is equal to 3.755 units. Okay, so we should found out that the length of AP that is equal to X, it is equal to either the square root of 19 minus 2 times square root of 6 all under square, or in terms of numbers, it is equal to 3.755 units. So in the next step, I will summarize the lecture. In the drawing, we have a regular hexagon, a regular regular hexagon is a closed polygon with 6 equal sides and 6 equal angles. All of its sides are equal to each other, and all of the 6 interior angles, those 6 interior angles are also equal to each other. We also know that line segment PB equals to 3 units, and side AB of the regular hexagon ABCDEF equals to 2 units. Therefore, all the other sides must be also equal to 6 units, and all of its 6 interior angles are also equal to each other. In the next step, we actually found out the sum of the angles in this regular hexagon or in any other regular hexagon. So here we have regular hexagon ABCDEF. This regular hexagon could be any regular hexagon. We actually join points B and D together by a straight line. By joining points B and E, we created those two quadrilaterals. The sum of the angles in this quadrilateral is 360 degrees, and the sum of the angles in this quadrilateral is equal also to 360 degrees. And because of the fact that this regular hexagon consists of those two quadrilaterals, it means that the sum of the angles on those two quadrilaterals must be equal to the sum of the angles in the regular hexagon ABCDEF. So 360 degrees plus 360 degrees is 720 degrees. This is actually also the sum of the angles on this regular hexagon ABCDEF. That could be any regular hexagon. Therefore, the sum of the angles in any regular hexagon equals to 720 degrees. And because of the fact that this regular hexagon, like any other regular hexagon, has exactly 6 equal angles, 6 equal interior angles, that are 2, 4, 6. Those are the 6 equal interior angles. It means that the sum of the 6 angles, that is 720 degrees, over 6, that is the number of the angles, must be equal to the size of one angle. Why? Because they are equal to each other. So 720 degrees over 6 is 120 degrees. So we found out that the size of this angle in any regular hexagon is equal to 120 degrees. So we can write down that all those 6 interior angles are equal to 120 degrees in their sizes. Okay. In the next step, we actually extended side DC by straight line. We created here line segment DL. DC is the side of regular hexagon. It is absolutely a straight line. Therefore, when we extended the straight line DC by straight line, we got DL. DL must be also a straight line. But because when you extend a straight line by straight line, the result must be also a straight line. So here we can write down that DL is a straight line. And we also have rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if you focus on the left side of the straight line, DL is point C. Here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at this side of DL is point C? We have this angle that is equal to 120 degrees plus the missing angle that is actually angle BCL. In total, they must be equal to 180 degrees according to rule number 1. And repeat again. According to rule number 1, 120 degrees plus the missing angle BCL must be equal to 180 degrees. We subtracted 120 degrees from this equation, and we found out that the missing angle BCL equals to 180 degrees minus 120 degrees, it is 60 degrees. So this is the missing angle BCL, that is equal to 60 degrees. Then from point B, we draw perpendicular on DL. Again, from point B, we draw perpendicular on DL. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the sine point, we define the touching point of the perpendicular from point B and DL as M. By doing this construction, we created the right triangle BCM. So I call it the right triangle BCM, and then you put it, we analyze triangle BCM. This is triangle CMB or BCM. This angle equals to 90 degrees according to our construction. This angle equals to 60 degrees according to rule number 1. CB equals to 2 units because it is 1 out of 6 sides of the regular hexagon ABCDEF, and therefore it is equal to 2 units. Because of the fact that all the sides of the regular hexagon are equal to 2 units. Okay, so in this right triangle CMB, cosine 60 degrees equals to CM over CB. CM over CB. CM is the missing side, so we leave it as it is. CB is 2, so we substitute CB by 2. And we know that cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2. In conclusion, we found out that 1/2 equals to CM over 2. We multiply this equation by 2 and we found out that CM equals to 1. Here CM equals to 1, and we can write down here that CM equals to 1. Likewise, in the same triangle, the right triangle CMB, sine of 60 degrees equals to MB over CB. Sine of 60 degrees equals to MB over CB. So sine of 60 degrees is square root of 3 over 2, so we substitute sine of 60 degrees by square root of 3 over 2. And MB is the missing line segment, missing side, so we leave it as it is. And CM is 2, so we substitute CM by 2. In conclusion, we found out that square root of 3 over 2 equals to MB over 2. Here we multiply this equation by 2 and we found out that MB equals to the square root of 3 units. Here MB equals to the square root of 3 units, and here also we can write down that MB or BM equals to the square root of 3 units. Okay? In the next step, we actually focused on the right triangle, triangle DMB. This right triangle DMB. DM equals to DC plus CM. DC is unknown. So actually triangle PMB. The right triangle, triangle PMB. So PM equals to PC plus CM. PC is unknown, so we define line segment PC as A. And therefore PM in total equals to PC plus CM, that is to say it is A plus 1. PM equals to A plus 1, BM equals to the square root of 3 units, and the hypotenuse PB equals to 4 units. So this is the right triangle PMB, that are coming from the original drawing. So I already mentioned before, PM equals to A plus 1, MB equals to the square root of 3 units, and the hypotenuse PB equals to 4 units according to what is given as the question. Here, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PB, therefore the square of the hypotenuse is PB square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM square plus MB square. PB is 3, therefore PB square is 3 square, that is 9, and it is equal to PM square. PM is A plus 1, therefore PM square is A plus 1 square, plus MB square. MB is square root of 3, therefore MB square is square root of 3 square. So in conclusion, we found out that 9 equals to A plus 1 square plus square root of 3 square. So 9 equals to A plus 1 square, and the square root of 3 square is 3. So 9 equals to A plus 1 square plus 3. We subtracted 3 from this equation and we found out that 9 minus 3 is 6, and it is equal to A plus 1 square. 3 minus 3 is 0. Here we took a root out of this equation and found out that square root of 6 equals to A plus 1. Here we subtracted 1 from this equation and finally we found out that A equals to the square root of 6 minus 1 units. So here we can write down in the original drawing that A equals to the square root of 6 minus 1 units. A is the value of line segment PC. In the next step, we actually joined point A and C together by a straight line. By joining points A and C, we created the triangle ABC. This is triangle ABC. In this triangle ABC, this angle equals to 180 degrees because it is 1 out of the 6 angles of the angle, so it is 1 out of the 6 angles of the regular hexagon ABCDEF, and we know that all the 6 interior angles of the regular hexagon ABCDEF are equal to each other, and each of them is equal to 120 degrees. Side AB equals to side BC equals to 2 units, because of the fact that those two sides are the sides of the regular hexagon, and all the sides of the regular hexagon are equal to 2 units. So this is triangle ABC. We actually implemented in this triangle ABC, the law of cosines in order to find out the length of side AC. We know that AB equals to 2, BC equals to 2, and the only missing side is side AC. What is the law of cosines? The law of cosines is true in any triangle. According to the law of cosines, if we have this triangle ABC, that could be any triangle, we know that the side AB equals to 1 units. Side AC equals to 1 units in its length, and side BC equals to 3 units. And the angle between side AB and side AC is theta. Then according to this law, the law of cosines, we get that c squared equals to a squared plus b squared minus 2 times a times b times cosine theta. Okay, and this equation is true in any triangle. C squared equals to a squared plus b squared minus 2 times a times b times cosine theta. Theta is the angle between side AB and side AC. We actually can implement the law of cosines in our triangle ABC. So I copied triangle ABC in a new page and implemented the law of cosines in this triangle ABC. Side AB equals to side BC equals to 2 units, and this angle equals to 120 degrees. The only missing side is side AC. So we implemented the law of cosines in order to find out the length of side AC. According to the law of cosines, AC squared equals to AB squared plus CB squared minus 2 times AB times CB times cosine 120 degrees. Again, AC squared equals to AB squared plus CB squared minus 2 times AB times CB times cosine 120 degrees. So AC squared equals to AB squared, AB is 2, so AB squared is 2 squared, that is 4, plus CB squared. CB is also 2, therefore CB squared is 2 squared, that is 4, minus 2 times AB is 2, CB is also 2, and cosine 120 degrees is minus 1 half, so we substitute cosine 120 degrees by minus 1 half. So in this expression we have minus times minus, that is 2, so in total this expression is a positive, and we have in this expression 2 times 2, that is 4, and 2 over 2 is 1, so those two will cancel, and we left only with 4. So in conclusion, we found out that AC squared equals to 4 plus 4 plus 4. 4 plus 4 plus 4 is 12, so AC squared equals to 12 units. We substitute 12 by 4 times 3, so AC squared equals to 4 times 3. We took out of this equation and found out that AC equals to the square root of 4 times 3 units. The square root of 3 is 2, so we took 4 out of the root, and in conclusion we found out that AC equals to 2, inside the root we left only with 3, so it is 2 times square root of 3. So this side AC equals to 2 times square root of 3. You can write down this original domain that AC, the length of side AC is 2 times square root of 3 units. Okay. In the next step, I copied actually triangle ABC again in order to find out the sizes of those two angles. This is triangle ABC that I copied from the original drawing. Angle ABC equals to 120 degrees, and side AB equals to side BC equals to 2 units. And we have the rule that in front of equal sides in the triangle there are equal angles. In front of those two equal sides, we have those two equal angles. So if this angle equals to x, this angle must be also equal to x because of the fact that they are equal to each other. And we also have the rule that the sum of the angles in any triangle is 120 degrees, and especially in triangle ABC. So which angles we have in triangle ABC? We have this angle x plus this angle x plus 120 degrees. In total they must be equal to 180 degrees. X plus x is 2x, so in this side of the equation we have 2x plus 120 degrees, that is equal to 180 degrees. We subtracted 120 degrees from this equation and found out that 2x equals to 180 degrees minus 120 degrees, it is 60 degrees. Here we divided this equation by 2 and found out that 2x equals to 60 degrees, so we divided this equation by 2 and we got that x equals to 60 over 2, that's 30 degrees. So this angle equals to x equals to 40 degrees, and this angle that is equal to x, it is equal to 30 degrees. So this angle that is actually angle ACB equals to 30 degrees. So we can write down that angle ACB in the original drawing, it is equal to 30 degrees. Then we actually have the big angle is angle PCB, this is angle PCB that is equal to 120 degrees. So we have the big angle PCB that is equal to 120 degrees. The small angle is angle ACB that is equal to 30 degrees. Again, the small angle is angle ACB that is equal to 30 degrees. Therefore, the missing angle, that is actually angle PCA, equals to the big angle PCB minus the small angle, that is ACB. Repeat again, the missing angle that is actually angle PCA will be equal to the big angle that is actually angle PCB. The missing angle PCA, this angle equals to the big angle that is angle PCB minus the small angle that is actually angle ACB or BCA. Okay, the missing angle PCA equals to the big angle PCB minus the small angle BCA. Okay, so the missing angle PCA equals to the big angle that is PCB that is equal to 120 degrees minus the small angle that is angle BCA that is 30 degrees. So the missing angle equals to 120 degrees minus 30 degrees, that is 90 degrees. So we found out that this missing angle PCA equals to 90 degrees, that is to say it is a right angle, and therefore triangle PCA is a right angle. Okay, this is the missing angle PCA that is equal to 90 degrees, and therefore the green triangle PCA is a right triangle. So I copied the right green triangle PCA in a new page, and we implemented in this right triangle PCA the Pythagoras theorem. This is the right triangle PCA that I copied from the original drawing, and according to the Pythagoras, here we know that PC equals to A, that is equal to the square root of 6 minus 1 units, CA equals to 2 times square root of 3 units, and PA, the hypotenuse PA equals to X according to what is given us in the question. And according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle PCA is PA, therefore the square of the hypotenuse is PA square, and it must be equal to the sum of the squares of the perpendiculars. This is to say it must be equal to PC square plus CA square. So PA square equals to PC square plus CA square according to the Pythagoras theorem. PC is X, therefore PC square is X square, and it must be equal to PC square. PC is square root of 6 minus 1, therefore PC square is square root of 6 minus 1 square, plus CA square. CA is 2 times square root of 3, therefore CA square is 2 times square root of 3 square. So in conclusion, we found out that X square equals to the square root of 6 minus 1 square, and 2 times square root of 3 square, it is actually 2 square, that is 4 times square root of 3 square, that is 3. 4 times 3 is 12. So in conclusion, we found out that X square equals to the square root of 6 minus 1 square plus 12. Here, in order to find out the value of this expression that is square root of 6 minus 1 square, we use the algebraic identity that states that A minus B square equals to A square plus B square minus 2 times AB. In our specific expression, square root of 6 minus 1 square, A equals to the square root of 6, B equals to 1. So according to this algebraic identity, we get that the square root of 6 minus 1 square equals to A square. A is square root of 6, therefore A square is square root of 6 square, that is 6, plus B square, B is 1, so B square is 1 square, that is 1. So it is 6 plus 1 minus 2 times AB. Minus 2 times A is square root of 6, and B is 1. So in conclusion, we found out that square root of 6 minus 1 square equals to 6 plus 1 minus 2 times square root of 6. So we can substitute square root of 6 minus 1 square in this equation by 6 plus 1 minus 2 times square root of 6. We did it, and we got that X square, instead of square root of 6 minus 1 square, we wrote down 6 plus 1 minus 2 times square root of 6, and we have also 12 plus 12. So here X square equals to 6 plus 1 is 7, and 7 plus 12 is 19. So it is actually X square equals to 19 minus 2 times square root of 6. Here we took a root out of this equation and found out that X, the line segment that we are looking for, X, AP that is equal to X, it is equal to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, it is equal to 3.755 units. I repeat again that this line segment AB that is equal to X equals to 3.755 units, so we can say that it also equals to the square root of 19 minus 2 times square root of 6 units. Okay, thank you very much.